Now this is, I think so, we did this some 3-4 lectures back. Yes, we did this some 3-4 lectures back, and we talked about the constant returns to scale. Actually, we talked about returns to scale in much detail there in the production function. So it says which of the following is true, and to solve this question, you start with the production function a to the power x, L to the power y. And let me just prove this to you first. So what should you do? Instead of k, you should replace it with lambda k. Instead of L, you should replace it with lambda L. And you will get lambda to the power x, k to the power x, lambda to the power y, L to the power y. And this will be your new production function, lambda k, lambda L. So you can rewrite this thing as, you can take lambda common, and you will get lambda to the power x plus y, k to the power x, L to the power y. And this will be lambda to the power x plus y into the initial production function. This will be your new production function. So if we notice, if this x plus y is 1, then we get only lambda with power 1. So that becomes a constant returns to scale. So based on that, my answer is x plus y is equal to 1, because the question is asking what is a constant returns to scale production function. So the answer is B. When x plus y is equal to 1, it is a CRS production function. It says consider a competitive market where demand and supply functions are given by this. Very simple. You're given a demand function 12 minus 2p, and you're given a supply function 4p. The tax rate per unit of the output that maximizes tax yield is. Okay. Now, this is a concept which we will actually do a little in macroeconomics also, as to what is the optimum tax that should be charged. So, usually, I'll just give you a gist here, but we will once read it in not completely macro also. It's a part of bits and pieces. It comes in Indian Eco also. We have something which is known as a Laffer curve. The Laffer curve says that as you increase the tax rate, the tax revenue initially keeps increasing. It reaches a maxima, post which it decreases. So imagine that if tomorrow the government tells you that I will charge 100% of your income as tax. If the government starts charging 100% of your income as tax, then in that case, you will stop working. There is no incentive to work. And if there is no incentive to work, then there will be no tax revenue collected because people are not working. So actually this Laffer curve touches the x-axis again, something like this it is drawn. And this means that zero revenue is collected even when there is a very high tax rate, maybe something like 100%, because nobody is working. And if nobody is working, no revenue is collected. So here tax rate is 0, here tax rate is maximum, but here tax revenue, this tax rate, it maximizes the tax revenue. This is a concept that is taught in Indian or in macroeconomics combined. But our question is not going to that aspect. This is just a concept. Now, what is our question saying? Our question is based on microeconomics only. It's based on the basic chapters of tax which are there in your very basic microeconomics, right? It's in basic videos of microeconomics if you have a look there. This just says that imagine you have this demand curve. So I take quantity here and I take price here. And I just want to plot this demand curve, 12 minus 2p. So when price is 0, demand is 12 units. And when demand is 0, price is 6, something like this. This is my demand curve. And then you have a supply curve which says when this is 1, when price is 1, quantity is 4, something here. When price is 2, quantity will be 8, and something like this. It will be this. This will be your supply curve. Currently, this is the situation. So if you want to find the equilibrium will be where demand is equal to supply. So 12 minus 2p is equal to 4p. 12 is equal to 6p. P is equal to 2. So at price 2, this is your equilibrium. And Q will be 8. This is your equilibrium quantity currently. Now imagine that there is a tax which is imposed. Let's say that the tax rate is T. So suppose a tax of T per unit is imposed. Whenever a tax is imposed, it will reduce the supply if it is imposed on suppliers and reduce the demand if it is imposed on consumers. We can impose it on anyone. It does not matter, right? The tax incidence is different. So when I charge a tax from consumer, we have done this in one of the classes, it gets distributed between consumer and producer. So here also, when I put a tax on, let's say, supplier, then the supply curve will shift backward here. This will be new supply curve. And the gap between the two supply curves, that will be the tax rate. That will be T, right? And if you go ahead and for that T, if you multiply that T into the quantity of equilibrium at that point, that will be your tax revenue. Okay, so your tax revenue is this square. It is the quantity, this quantity, whichever is the new quantity equilibrium, into the tax rate. That's that rectangle, that is your tax revenue. The aim is to maximize that tax revenue. This is what the question is saying. What is the tax rate per unit that maximizes the revenue? What is that T which maximizes my revenue? So let's say that I charge a tax rate of T. Now, what will be my new supply curve? Initially, my supply curve was 4 into P. Now, for each unit, the price received by the supplier will be P minus T. Because whatever price he receives from the consumer, he pays a tax of T to the government, and the net price he receives is P minus T. So whenever there is a tax that is imposed on the supplier, you will always, subtract that tax rate to get the net price received by the supplier. Had I assumed that the tax rate will be imposed on the consumer, then the consumer will pay price to the supplier and will also pay tax to the government. So if I would have imposed the tax rate on consumer, I would have done 12 minus 2, and instead of P, I would have written P plus T. Because consumer will end up paying more price after tax. So whenever you do from the side of consumer, you will always do P plus T. Whenever you will do from the side of producer, you will always do P minus T. And this will always remain the same. You have to follow this practice throughout. So supposedly I am charging a tax rate on the supplier. Achha, both of them will give you the same answer. So suppose I charge a tax rate on the supplier. This is my new equilibrium quantity, and at equilibrium demand is equal to supply. So my demand was 12 minus 2p. So 12 minus 2p is equal to 4p minus 4t. So I will get 12 minus 2p minus 4t is equal to minus 4t. 12 minus 6p is equal to minus 4t. So minus 2t is equal to 6 minus 3p. And t will be 3p minus 6 divided by 2. This is my tax rate. And now, if I want to go ahead and if I want to find out the tax revenue will be tax rate into quantity, right? So it will be 3p minus 6 by 2. This is the tax rate into the quantity. What is my quantity that I'm selling? I'm selling 4p minus 3. This will be your tax revenue, right? You just have to maximize this tax revenue. Whichever tax rate maximizes this tax revenue, that will be your optimum. Now, you could have done exactly the same thing with the other aspect also. So as I just mentioned, instead of going ahead and instead of doing it like this, instead of subtracting it from here, you could have found the equilibrium the other way also. So you could have done that quantity demanded is equal to 12 minus 2. And instead of price here, you would have written P plus T. Quantity supplied would have been 4P. And then by solving this, you would have got 12 minus 2P minus 2T is equal to 4P. So you would have got 2T is equal to 12 minus 6P and T is equal to 6 minus P. If you would have charged from the consumer, you would have got this. But after finding the final equilibrium, the answer would have been the same. So you either charge it from the consumer or you charge it on the producer. The answer, the final answer that you will get for the optima quantity will remain the same. The only thing that you have to remember is if I am charging my tax on the producer, then I'm going to shift my supply curve upwards. But if I'm charging my tax on the consumer, then I want to shift my demand curve downwards or backwards. So this thing has to be clear to you. When I do this, then also the gap between the two demand curves is the tax rate. And multiplying that tax rate with the quantity, that is going to give me the tax revenue.